All right, guys, good afternoon. How's it going there? Welcome back. We have about 3 minutes until 1 p.m. So I'm just getting the stream started, but I hope you're doing really good and had a solid weekend. Hi, Chelsea. How are you? Hi, Dimitri. Sunny. Yeah, my weekend was nice. I didn't have too much grading this time, so I was able to just really relax and get in some extra sleep. So it was nice. Hi, Hannah. Nancy, Ray, welcome back. Hey, Danny, Stacy. Good to see you guys. Emily, hi. Danny and Nick, hello. Okay. Just a little over a minute. A friend got me one of these hydro flasks for a gift. It's pretty amazing, I gotta say. Like, I can't believe how cold the drink stays for so long. Like, we put ice in there. Because I was just running yesterday out at the track, right? And it was pretty hot. It was like 85 degrees. And I had it out there full heat and heat just sitting for like an hour. And the ice was still all fully intact. It's still really cold. So I was like, wow, this is actually pretty good. Should have had one all these years. Welcome back, guys. Diane, Alexa, Margarito. Hello. Hi, Cecilia. All right, then. So now that we're pretty much there to 1 p.m., I'm just going to get things underway. Good to see everybody, like I was saying, and thanks for your attendance and all of your hard work through our semester. A couple of basic things that we already know, but just to remind you, the third homework assignment is due this week before the end of the day on Wednesday. So you have still got some additional time to finish that one, but make sure that you're at least starting to try and complete the project because, yeah, you don't want to do it all at the very last minute. Anyway, that's the advertisement fallacy homework. So it's due as an email to me anytime before midnight on Thursday night, and I'll just go through the inbox and make sure I confirm each one, before the end of the day on Thursday. Other than that, we're starting a new chapter in the book today, and then we're going to have a quiz on this chapter a week from today on Monday next week. So we're going to try and get in the material on chapter 12 this week. So a new chapter for our book. What we're talking about now is science. Okay, so obviously another important aspect of being a good critical thinker is being able to evaluate and understand information that we hear provided to us by the scientific community, whether that's in mainstream media or whether it's in scientific journals and other forms of media reporting on scientific conclusions. I'm going to try today to talk to you a little bit about some of the history of science, taking us back to earlier days of Western science. We'll identify some of the basic assumptions that science makes and that scientists make within the field. We'll talk about the steps of the scientific method, what are qualities of a good scientific theory, and then we'll talk about how to distinguish between real science and junk science, sometimes called pseudoscience. So as many of the chapters of our book in the past, this one also starts with just a little reference to a real world issue to kind of get us into the thinking about what the topic of the chapter is. And so they start off by just going into the facts concerning global warming. Global warming, as I'm sure you guys have heard, is a growing issue that we have to face in this 21st century and beyond. Basically, the aggregate effect of carbon emissions from human industrial processes and energy use accumulate in the Earth's atmosphere. Over time, this produces what's known as a greenhouse effect, basically trapping heat in the planet's atmosphere. And what that actually causes to happen slowly over time is for global temperatures to increase. And based on the data that we've collected in the last 150 years, we've noticed the sea levels starting to rise, and they've increased by over 7 inches in the last 100 years. Why is that? Because of the effect of melting Arctic sea ice brought about by these accumulating greenhouse gases in the Earth's atmosphere. And there's concern about the effect of further erosion of the Arctic ice sheets, because according to at least some models, if we continue to see a warming trend on the planet into the next 100 years, some people reasonably estimate that we could see as much as another foot of sea level rise by the turn of the current century, by the end of 2100. And that's a huge concern for people living in coastal areas, not to mention people all around the world, but those of us living in coastal areas would have concerns, because if sea levels rise by another foot, it would cause significant damage to the coastal areas and wetlands, and it would make it harder for human beings to inhabit places that are so close to the coast without significant geoengineering or significant costs that we would have to bear to offset the effects of the rising sea levels. In recent decades, the heating trend has accelerated. As it's stated here, the hottest 14 years since the year 1850, since we've been collecting global measurable weather data, have all happened since the year 2000. And like in the last several years, we've seen like record-breaking global temperatures. So if you were to look at like a graph of global temperatures, you would see it all spiking up and accumulating towards the tail end of the graph as we get towards the current day. So it's a scary situation in a lot of ways, because if we could not possibly manage this, it would pose significant threats to our future ability to survive and thrive as a species on the planet. Whole coastal regions could be submerged in water with all the resulting harms to property and infrastructure, as well as you could imagine. So as critical thinkers, we have to be able to interpret all this information that we hear from scientific theories and reports. We have to be able to evaluate the information and determine how best to use it so that we can take the right actions for ourselves, for our friends, families, and our communities. So let's start, I guess, with just the basic description of what science even is. And this is the sort of term definition that we see in the book. Good to see everybody. I see you guys showing up, and thanks again, as usual, for being here. So science, first of all, can we give a clear definition? The book attempts one, and what it says is this: science is essentially reasoning from observable facts to testable explanations for the facts. Okay, so what it says is science, reasoning from observable facts to testable explanations for the facts. So with science, we start off just with observation of the world, and we just observe and identify that given phenomena are happening. And then the goal of the scientist is to try and explain the cause and effect relationship between whatever we've observed and what caused it. So we want to know why things happen. We want to be able to understand processes in nature, and according to physical laws, we want to be able to understand why certain phenomena are observed and what their underlying cause is. So It's the major source and method for getting knowledge about the world. If you want to know how something works or why something happens, the best field that you could defer to would be the scientific community and get the best high-level scientific explanation for that phenomenon, whether we're talking about processes of weather, biological life processes, physical laws, the propagation of electromagnetic waves through space. In any case, whatever it is that we want, photosynthesis, right? Processes of reproduction and mating within the animal kingdom, the respiratory system, etc. Any of these different things could best be explained by the scientific consensus theory of it. And so, you know, if you're a pre-modern person, imagine, you know, way back in the past, and you saw a volcano go off, you would see it, you'd live with the consequences of it if it did damage to the area or if it made it uninhabitable. But unless you were doing science in some kind of systematic way, you would never really understand why did it happen. You would not understand that, you know, pressure builds beneath the surface of the earth, and eventually this causes the ejection of hot magma from the core of the planet. So with science anyway, we want to just not have stuff happen and then like, wow, it happened, I have no idea why, but rather to be able to provide an explanation for the facts that are observed. So whether it was a volcano, an eclipse, et cetera, we want to be able as scientists and human beings to master the knowledge of why things happen. Because it's only by knowing why something happens that we can exert some control over the things happening in nature and insert ourselves into the picture in a way that provides us with better outcomes for human beings. So science begins by observing facts and then trying to create explanations for the facts that are observed. And these explanations that are generated are supposed to be capable of being tested for their accuracy. So a scientist doesn't just say, hey, take my word for it, here's how the volcano works, don't ask questions. They say, no, here you can provide the basis for an experiment, which you could use to test whether my explanation is correct. So science always comes packaged together with testable explanations. They don't just say it's a given and no one can challenge it. They say, no, it's been established and somewhat confirmed based on empirical testing. So science tries to give us testable explanations for the facts that are observed. Now, science hasn't always been with us. Prior to around the 17th century, late Renaissance, sometimes people call this point in time, the 17th century, the 1600s, like the age of reason. Prior to that, though, the church, and in the West, the Christian church, from the beginning of the Christian era, around 0 AD, up until the 1600s AD, that's the early Christian era and the medieval period. And during that whole time, religion was said to be the sole source of truth in the Western world. So back then, if you were like a student, as you are now, there wouldn't have been the separation of church and state where, you know, you go to Sunday school or whatever religious practice that you have to like learn lessons from your religion, and then you go to school and you study like topics that are secular like we do. No, back then it would have all been mixed together. So your education would have been infused with ecclesiastical and theological lessons, and people would have just been expected to hold true to the doctrines of Christianity and religion. But as the church sort of waned in its power and influence, and we started to see this explosion of secular and scientific knowledge, that's when science really gains footing. And there's some important figures in the early history of Western science that the book mentions. So I want to just at least mention two of them, even though we could obviously refer to more. Good, Peachy. Good girl. Sorry, just got to move over there. Okay, so who are some of these important figures in early history of science in the West? Well, one person who we can give credit to is this man named Copernicus. Let me make sure I'm spelling his name properly. Yes. Okay, so Nicholas Copernicus, one important figure that we just want to know a few facts about. He was born in 1473, and he lived until 1543. So, who was Mr. Copernicus and what was his big contribution? Well, he is, in some circles, credited with launching the scientific revolution because he discovered what is called and what is known as heliocentrism. So, just a little brief statement here. He was a Polish astronomer. who discovered the heliocentric model of the solar system. And the heliocentric model, this replaced geocentrism and the geocentric model. Okay, Polish astronomer discovered the heliocentric model of the solar system, and that did replace geocentrism. I wonder if any of you guys would be willing to take a guess as to what that means, like based on the wording itself, or if you have prior knowledge of your own, you might be able to tell me, or even just make a reasonable guess. What do you think it is to discover the heliocentric model of the solar system? What do you think that discovery was? I mean, I will tell you, but I'll give you an option or an opportunity to say if you know. So what do you think it would be, or was, the discovery of heliocentrism? And how is that different from geocentrism? Let me know. That's correct, Edward, yes. Heliocentrism is the concept that we orbit around the sun instead of the other way around. The earlier idea, correct, Margarito, that planets orbit the sun, that's heliocentrism. So helio, it refers to the sun. Centric means centered. So heliocentrism is sun-centered model, the sun at the middle with the planets rotating in orbit around it. Prior to that, the belief was geocentrism, and that was like a very important doctrine for people to hold to before both Copernicus and also Galileo. He's another person who used newly invented telescopes to verify that we are not at the middle, and instead it's the sun. Why do you think geocentrism, the Earth-centered model, was so important to those early generations of Western thinkers? Well, it was out of deference to the idea of religion. What they believed was that God, since God's the creator of the universe, according to obviously Christianity and religion, and according to that doctrine, we're created in the image of God. So we're supposed to be kind of like special creations, you know, more important than like insects and lower animals, right? So God creates the universe for the sake of man, and we are made in the image of man. And so according to the religious Orthodox view, we should have had a central position. You know, we should have pride of place if the universe is built as a place for human habitation specifically. So then you would expect we'd be right in the middle and everything would revolve around us. That was so important to the early church that, in fact, when Galileo started to prove and write about the heliocentric concept, he was forced to recant his testimony in public. Actually, they threatened him with death, even though he was up in his 70s and half blind from looking at the sun through telescopes. They forced him to say, never mind, I don't know what was wrong with me. I must have been possessed by the devil or something, but I was kidding. It's not sun-centered. But obviously, you know, he was right, and nobody has any doubt about that anymore. It's easy enough to verify it given the present technology that we have, but it was already known back then in those earlier days of the West. The church has formally apologized to Galileo and his descendants since then. But anyway, at the time, it was a big deal to suppose that the Earth was not at the middle of everything. It would have sounded to some people back then as though like a big rejection of religious orthodoxy. So Copernicus is one important figure of early science because of his discovery of heliocentrism. And besides Copernicus, they also make mention of this man named Sir Francis Bacon. So let me just tell you a little bit about him too. Okay, so Francis Bacon lived from 1561 until 1626. And his big contribution that, you know, his legacy item is that he established what we call the scientific method. So formulated the steps in the scientific method. We'll talk about these steps in like more granular detail in a little bit, probably on the Wednesday meeting this week. We have two meetings on science, so just part one today. But Sir Francis Bacon, that's his legacy and his major contribution to have formulated the steps in the scientific method. So the scientific method is a process by which we try to develop hypotheses and theories for phenomena that we observe. In the method that we take, we start by observing something, trying to then give a hypothesis as to why it happens, testing the hypothesis to see if it proves the theory, and if it doesn't, then we have to create a different hypothesis, or if the test confirms the hypothesis, then we allow it to be published so other people can replicate it. So that kind of scientific method where you start from observation, hypothesis, and test, this was kind of the main contribution of Sir Francis Bacon. And we of course still use the scientific method in every scientific field today. So just another classic figure to pick out a couple, even though other names could have been added as well. So the next part in chapter 12 talks about what are some of the fundamental assumptions that are built into science. What are certain things that the practice of science has to assume and does assume, but cannot necessarily prove. So these are kind of like stage setting given assumptions of science that are required for science to even be done. So let's write it as such: assumptions behind science. Okay, assumptions behind science. So one of these assumptions is a term that we've actually encountered earlier in the semester, but now it's coming back again, and the word is empiricism. You may remember the word. I know I asked you about it on the, I think, the midterm. But empiricism is a school of thought about where most human knowledge comes from. Do you have a memory of what it means? Let me see if you could tell me. If you have it, then just put it out there. Empiricism says that most of our human knowledge comes from what source? How do we learn things? How do we know things? Where does knowledge come from according to this standpoint? Who knows? Anybody? Empiricism. Just checking in with you. If you know, go ahead. Don't hold back. Let me know what the definition is if you think you know. Yeah, okay, Yvonne. You say senses and experience. That's the answer as to where does most human knowledge come from. Correct, according to this school of thought. So yes, it's the belief that most human knowledge comes from the 5 senses and observation. Now, I noticed that when a lot of people would answer this question on the test, they would put observation in plural. What's that all about? I mean, it's a singular term. So observations are like you conduct multiple observations, but observation as a noun is a singular because it's a concept. Anyway, empiricism, the belief that most human knowledge comes from the 5 senses and observation. That's one view about where most of our knowledge comes from, and that's built right into the practice of science. Because as I was telling you guys, science starts from the observation of facts, collecting data by means of observing things. And if we didn't think that we could gain knowledge starting with what we could observe, then science would have no footing at all, because science is all observation-based. It's the basis. It's based on creating testable explanations from observed phenomena, from observed data. So if we didn't think that by means of observing things we could derive knowledge, then science would just be pointless. So science does assume, therefore, that we can gain knowledge and that most of our knowledge does come from what we can observe, either by means of our 5 senses or through tools and technologies that we create to augment our 5 senses, like microscopes or stethoscopes or telescopes. Okay, so that's one assumption of science, the assumption of empiricism. Another assumption, now that we have it, I'll erase, is what's called objectivity. So let me give you that definition and explain a little bit too. So the second big assumption behind science is the assumption of objectivity. It's the letter E. Okay, objectivity. And the idea of objectivity is this assumption or belief. It's the belief that we can learn about the physical world as it really is and with no bias. Okay, so okay, so objectivity. The concept of the objective is the concept of what actually exists in objective fact and not sort of what is perceived subjectively by a person's personal judgment or bias or whatever. Let me try and distinguish for you guys between the idea of what's objective and what's subjective and see if maybe your own common sense will help you answer these questions. So if I told you that, let me ask it, let's see. If I say to you that vanilla is the best ice cream flavor, vanilla, would you tell me or say that that's a subjective statement or an objective statement? The statement that vanilla is the best ice cream. Subjective or objective? What do you think? I'm giving you just those two choices, and maybe you'll tell me which of the two you think corresponds to the statement that vanilla is the best tasting ice cream. Is that subjective or objective? Okay, so Yvonne, good. You say that that's subjective. Can you give me any view as to why? I mean, that's correct. And Danny, you add some reasoning, so let me read your comment. You say subjective mainly because you have bias for vanilla. Well, I guess that's one way to put it. But it basically is subjective. Yeah, Danny, it's subjective. And the reason is because it's dependent on my own taste and my preferences. And those are different from person to person. One person can think that vanilla ice cream is boring, and they can say it's my least favorite. And I can say, oh no, it's very good and neutral and it pairs well with toppings, and I think therefore it's the best flavor ice cream. But we have our different opinions on the matter, and there's no like objective fact. It's not like, as a matter of fact, no, it's wrong, or yes, it's correct. So that's just a sort of subjective point of view. So subjective things are things that depend on the person's personal perspective, and they may not be like factually correct in some like objective sense. But if I told you that we are the third planet from the sun, can you guys agree with me that that's objective and not subjective? That's not just based on how I feel. That's not just based on my attitude or opinion, and we can agree to disagree. It's just an objective fact, isn't it? That we are objectively the third planet from the sun. So that's just what exists out there. Whether you like it or not, whether you agree with it or not, it's an objective fact. Okay, so objective things are just the facts being what they are, regardless of anybody's personal point of view or opinion. And subjective things are the things that we can just view from our own lens. You know, like if I think that such and such is the best musician or artist or ice cream flavor, these are my subjective views and opinions. Now, in science, we assume that objectivity is possible. So we assume that we actually can learn about the world as it really is. Not that we can only talk about our personal feelings and associations that come from our subjective point of view. Science believes that we can get to the real hard truth and the ground facts about reality, and that when we get there, we will not just be exhibiting our own bias or personal point of view. Science strives for objective truth, not personal opinions and skewed biased viewpoints on reality. So if we didn't think it was possible to get to the objective truth, then what would be the point of doing science? You know, there would be no point because it's in the pursuit of the truth. So science at least assumes the possibility of getting to those truths, and that when we get there, we will be doing so with no bias and we'll just be perfectly objective. Okay, so there's an external world out there. It's not just a world of your own imagination or dream. There's an external world out there, and according to the assumption of objectivity, we can learn about it as it is in fact, not just as it appears to be. We can get to the reality, not just the appearances, and we can do it without bias. Okay. So good. I mean, I know we talked about Descartes like earlier in the semester for just a moment, and Descartes said, hey, how do you know you're not even dreaming right now, and this is all a simulation? Well, if there was no real external reality, then there would be nothing for science to study. You know, if you're Mario and you're in the Mario Brothers universe, there'd be no point to studying the science of your environment because it's a totally simulated environment. So science assumes that we are in a real world. There's an objective world out there. It's not just all subjective dreams or illusions or hallucinations. There's an external world which is real, factual. We can discover what it's like and we can do it without bias. Okay, so in a way it contradicts the view of total skepticism, which is that who knows what's true or if we could ever discover it. In science, we at least hold out the hope for objectivity. Okay, and then another main assumption of science is the view of, or the idea of what's called materialism. Now I want to start by making sure that nobody has the wrong understanding of the word materialism, because there's a different meaning of it that has nothing to do with its philosophical or scientific meaning. And let's make sure not to think of it in that way, at least for the purposes of this class or this chapter of the book. Sometimes when people use the word materialism, they refer to somebody who's like obsessed with material possessions, the way they look, and just, you know, having objects like cars and houses and clothes and jewelry. But that's not what materialism means in the scientific sense of the word or the philosophical sense. So let's set that other meaning to the side if that's the first thing that popped into your head. Materialism in the sense of science and philosophy means something much different, and it's this view. It is the view that everything in the universe is made out of physical matter, including us and our consciousness. Okay, so including us human beings, and our consciousness. Physical matter, including us and our consciousness. That's what is the view of materialism. So what this basically says is that everything's made out of matter. Everything's physical. Everything, not just most things, not even just 99% of things, but 100% of all things, even including us, it's just made out of matter, physical matter. Now, I have a question. Who has in their mind the idea of what is the most basic unit of physical matter? Like, what's the smallest bit of physical matter that you can't break down further? There's a common word, anyway, in our vocabulary which expresses this. Good, Micah, the atom. Now, I know if you guys, any of you have studied physics, that you've heard perhaps about some subatomic particles like quarks and so on. But let's just stick with the term atom, because at least classically, going back all the way to ancient Greece, this was the first term used for the least unit of matter. Atom actually means in Greek originally like uncuttable. So it's the thing that you can't break down into further smaller parts, the uncuttable tiny little atom. So with materialism, guys, the idea is that everything is made out of atoms. Okay, everything is made out of atoms, just grouped together to form different objects. So like this hydro flask that I was talking about, it's made out of atoms. It's just a bunch of atoms put together a particular way, hydro flask wise, causes this thing to exist. This table that the items are laid upon is also just an object that's made out of atoms. It's a physical object made out of atoms, the least unit of matter, put together a bunch of those atomic particles and you get a table. But on the materialist view of the world and the universe, it's not just inanimate objects that are made out of matter, so are me and you. So according to materialism, a human being or any other life form is just a very complex and sophisticated biological life form, but it's made out of atoms too. And so me speaking to you, giving you this lecture, is just a big bundle of atoms arranged in a given way, and it gives rise to a life form which has got consciousness. And you, on the other end, hearing this lecture, would be also considered to be like a big bundle of atoms pieced together in such a way that it forms a human organism which watches a lecture on YouTube. So it's denying that there's anything non-physical about our consciousness and our own being. So on the materialist viewpoint, there is no such thing as the soul. There would be no possibility for a disembodied consciousness. So as you guys know, ashes to ashes, dust to dust. Eventually, the body just decomposes and it's literally just a skeleton or just dust. At that point, there's no longer any brain which could exist or function. And on materialism, since everything's made out of matter, consciousness is just a byproduct of the physical brain operating in its environment. But when the brain ceases to function, or literally just decomposes into dust, the materialist perspective would say there's no consciousness left, because consciousness cannot just like float free space without the brain exhibiting the cognitive function that we see as thought and perspective and mental life. So the materialist view says it's all made out of matter. Human consciousness and every other thing is made out of matter too. So if there was not a physical support for consciousness, then it wouldn't just exist independently. So it kind of does deny the existence of the spiritual world or the afterlife or anything that was not just made out of mass and atoms. Does that kind of make sense to you guys? I mean, I'm not trying to say it's true or false, but it is a view that's a core assumption of science. Now, there are many people who are working scientists who still hold their own religious views, but insofar as they're in the field doing their work, methodologically at least, they assume materialism. So there's no room in science for like ghosts and spirits and like, you know, ESP or any of these kind of forces that have nothing to do with what we understand scientifically through the properties of matter and atoms. Okay, so materialism, another big assumption behind science. So far, so good. Hopefully so. Let me know if you have any issues with this, but I'm going to continue. There's a couple more big assumptions of science to add to the list, so 2 more. About materialism, one last thing. Sometimes I've seen it labeled with a different term in other books and materials. I've seen it also called physicalism. In my own view, I think that's actually a better name, because physicalism doesn't call to mind any of those false associations with the term materialism in its non-scientific usage. So physicalism, I think, is another way of referring to it, but since our book just goes with the old school word materialism, I'm using the same. Okay. Next, another assumption found in science is the assumption called predictability. Predictability. So this assumption is just that the universe overall is orderly and predictable, meaning that established cause-effect relationships will be repeatable and will hold forever. Okay, so the universe is orderly and predictable. Orderly and predictable. So established cause-effect relationships will be repeatable and will hold forever. Okay, so universe, orderly and predictable, meaning that established cause-effect relationships will be repeatable and they will hold forever. So let me try and demonstrate this concept with a little illustration here that we can all follow just with me using this marker. Okay, so I've got the marker here and I'm holding it above the table at like this height in my hand. As you can see, it's held in the air because I'm grasping it with my fingers. But what I'm going to do is I'm just going to release my grasp in a moment. And I just would like to ask you for your prediction. What will happen if I release my grasp on this marker? I haven't done it yet. So let me hear your prediction before I do it. What do you think would be the case? I mean, I open my fingers, I'm holding the marker, I'm holding it above this table surface. Margarita, you say it's going to fall onto the table. Okay. Now, I would tend to agree with you, but let me just play devil's advocate for a bit. I don't know. You say it'll fall to the table. Okay, good. We're all on the same page. We can agree to that. But why do you think it will fall to the table? Why do you think so? Okay, Jay, you say gravity will do its thing. Okay. Why do you think gravity is going to work today, though? Why will it work today? I mean, again, I haven't tried to do this yet. So what is your basis for thinking that gravity will still work today? I mean, I know you're saying gravity, gravity, gravity. Because it always did work in the past. Isn't that right, Margarito? Okay, good. So what is the reason that you think that just because it worked in the past, it will always work in the future? Well, Margarito and Jay, and same to you, Micah, you're saying precedent. Well, what you're saying is actually expressing confidence in this principle. Because what you are saying is because gravity has always worked, it's not going to change. The same process, but it will happen again if I do it today and tomorrow and any time after that. So what you're saying is, what this says, that the universe is so orderly and predictable that, for example, gravity, the effect of gravity on a falling object will be repeatable, and that's not just like a random thing that's going to happen temporarily, but that it would continue to happen forever into the future. Okay, well, yeah, Jay, I know that you're saying you're not floating around and gravity's pushing us down, but what about after you wrote that? How about today at 5 p.m., gravity just stops? How do you know that won't happen? Well, I guess you can't say you actually know for 100% certainty, so you just make what's called an assumption that it will always hold into the future. So making a judgment that the laws of nature will continue to apply requires you to kind of almost take like a leap of faith, as it were. And that's the assumption here of predictability. We can't guarantee that these laws will always function in the same way, but we make the assumption. And so Yvonne, again, yes, it is induction. Induction is making us think that because we've observed the phenomena in the past so many times, that we will observe it in the next observable instance too. But even induction relies on this assumption, because what makes you think that induction will continue to show us what the future will be like? Well, you'll say because in the past it always worked. But what about the future, not the past future? We haven't been to the future yet relative to this current moment in time. So we just have to have an assumption that it will always function. Anyway, let's try it. I'm going to let it happen. Prediction was correct. It did fall. What if I do it again? Will it fall again? And I'm assuming your prediction would be the same, right? So for how long could I continue to repeat this process if I had unlimited time? How many times would it fall if I had infinite time to keep demonstrating? Well, I assume your answer is that it would fall for all time, because the function of gravity is not going to stop. It's not going to stop overnight or tomorrow or at any time in the future. So the predictability assumption is that the laws of nature that cause these cause and effect results to happen are permanent laws. They don't change, they will hold forever, and if we can establish the same parameters, then the same result will be seen over and over again to infinity for all time. So that's another assumption of science. And why is it an assumption? Because as I've just said, we haven't seen the future yet. So we're predicting that the future will be resemblant of features that we've seen in the past. And that requires this assumption that the laws of nature are stable, that the universe is predictable, that the universe doesn't behave in an unpredictable way. So for example, if I was to release this thing, and instead of it dropping, it just floated for a minute and then turned into a chicken and just floats off into the air, you'd be shocked and you'd be like, wow, the universe is misbehaving. It's not predictable anymore. It always was the case that when you drop something from a free height, it falls. Now all bets are off. So predictability assumes that it's a safe bet and there's actually nothing that will ever contradict it, that the laws of nature will function in a predictable and orderly way for all of time. Okay, so I was trying to make that clear with the little marker example, but any other example would suffice. If you can isolate a cause-effect relationship, the scientific view of predictability says that this relationship will be repeatable if the same kind of antecedent circumstances arise, okay? So like, I don't know, the physical facts which cause a jolt of electricity to course through a circuit so that it powers your electrical devices, that would work the same way if we were to create a very similar type of electrical device using the same laws of electrodynamics. So the idea is that those laws are stable, predictable. Once we know how they work, they continue to work the same way forever, not just for a limited time, and not just for a limited space either, right? So I'm dropping this marker from a free height here on the planet Earth. But if there were another planet with similar gravitational features as our own, then going to that planet and causing the same result would show the same outcome. Okay, so much for predictability. And then there's just one more main assumption of science that the book refers to, and that would be what it calls unity. So the assumption of unity is that there's an underlying unity to the universe, meaning that everything eventually could be explained according to a single set of scientific laws. Okay, so the idea is such that everything can be explained according to a single set of scientific laws. Okay, unity to the universe, meaning that everything can be explained according to a single set of scientific laws. So it's basically saying that there's just one set of rules that governs the operation of everything in the universe, not that there's two sets of rules, like one for some physical phenomena and then another set of inconsistent physical laws that govern the operation of different physical phenomena. No, instead the belief here is that all things, from the biggest to the smallest events of reality, can all of them be explained according to one unified set of scientific laws and physical laws. This is actually what sometimes is called in science the Grand Unified Theory, or GUT. It's not been achieved yet, but this idea of the Grand Unified Theory is like the sort of holy grail of science. It would be the idea of a set of physical laws that could by themselves explain everything from top to bottom, to the formation of galaxy superclusters, all the way down to the behavior of little quantum particles of the universe. What we actually have now, though, is we haven't gone all the way towards the fulfillment of this theory, or idea, assumption, because as of today, we have the theory of relativity and Einstein's work on the electrodynamics of moving bodies, which explains the behavior of large-scale physical phenomena. But then when you get down to the tiny little nanoscale, quantum physics explains that. And there are actually some contradictions and inconsistencies between quantum theory and the theory of relativity. So the Grand Unified Theory is still a project for future science to achieve. We think that at some future time, we'll be able to unify both sets of principles and laws into one elegant and unified system of physical laws to explain everything. Why shouldn't there be only one set of laws? Because after all, there's only one universe. So people think it would be weird if there's one set of principles for small scale phenomena and another set of principles for the larger ones. So if we can eventually build that bridge between quantum theory and the relativistic theories of Einstein, then we will have achieved the assumed goal here, which is that there is one master set of universal scientific laws if we could just discover what they were. Okay, so anyway, those are some basic assumptions behind science. The next thing I want to do is talk to you guys about, what are some limitations of science? Like, what are some things that science cannot prove, but it has to assume to be true anyway in order for science to function? So limitations of science. I don't want to spend too much time on this part because I thought it was very philosophical and therefore hard to create like simple bullet points for you, but I'll talk to you about them. Okay, so one limitation is science assumes that the external world exists, which cannot be absolutely proven, okay? So okay, so once again on the topic of Cartesian skepticism, he says the method of doubt would imply that you should assume to be false anything that could possibly be doubted at all. Not to worry, Dylan. I'm glad you're here. Hopefully everything's okay. So let me know if there's anything you need, but hopefully you're all right. Sorry about that. Yeah, the external world. So look around you, right? You're probably sitting somewhere in like an apartment or house where you live or whatever, and you can see around you the familiar surroundings of that room and etc. But what if I told you, who knows if this is all a big dream that you're having, so there actually is no external environment and you're just living in your mind? You'd probably think, well, I don't know, I guess I can't prove that, but I just assume there's an external world because it really seems like there is. Science assumes the same thing, right? We assume there's an external world, that you're not just living in a big simulation or dream. But at the end of the day, this is something that cannot be absolutely proven, because suppose for the sake of discussion that you were right now in a big simulation. If it was a very good simulation, what would it look like? It would look exactly like this, because suppose this is a real experience, then the simulation version of it would be identical to it in all qualitative respects. So you'd never be able to tell the difference between living in the matrix and living in real reality. At the end of the day, though, science assumes that we're not in the matrix and that this external world is real, and that's what we're investigating scientifically. As I said before, there would be no point at all to searching for knowledge and information about anything if it was all just a big hologram or hallucination or dream that you're having. So science assumes that the external world exists, but we kind of have a limitation there because there's nothing that can be done to prove it beyond all possible doubts. So it's just something that has to be assumed. There is an external world. I'm sure you don't doubt that there's an external world until maybe you take a philosophy class. But even if you've taken a philosophy class, just understand that for science and scientific purposes, we set all those strange, skeptical concerns aside, and we just hold the assumption that the external world exists, whether we can prove it or not. Okay, another limitation of science is that it can only study things that are observable. So some think of this as another limitation of science, because science cannot study things that are in principle unobservable. So whether it's direct or indirect, there has to be some mechanism that you could use to observe a thing if it's even within the realm of scientific investigation. So like, for example, if there was something supernatural or paranormal, like ghosts or like the afterlife or God, that would be permanently outside the realm of science, because science can't deal with things that you cannot observe either with the five senses or with measurement instruments that we could build. So some people see this as a big limitation. Even outside the realm of the supernatural, there are some, kind of troubling issues with this. One thing that's fact is that the universe and all the matter of the universe is becoming less dense. It's expanding outwards very rapidly. So we're in a universe that's rapidly expanding in size, meaning that it's becoming less dense and concentrated in terms of the matter that is found within. And some people are not sure what's fueling this outward expansion of matter, because it's not necessarily explicable merely on the basis of the ejection of matter outward from the original Big Bang. Since gravitation affects a attractive force, we should expect that would cause these things to condense and to even contract. So what's the fuel behind this outward expansion? Now, one theory of that is that it's what's called in science dark matter, that there's some type of dark matter that's undetectable by normal means, and this is somehow pushing the expansion of all matter outwards in the universe. But if there is such a thing as dark matter, it's very hard for the scientists to comprehend, because dark as it is, it's incapable of even indirect observation. So anyway, there are sometimes ways of getting around things that used to be unobservable, making them observable through tools like cloud chamber allows us to observe indirectly the behavior of elementary particles. So with technological advancement, some of the things that were previously unobservable become observable to the scientist. Nonetheless, if there is anything that's either currently or permanently unobservable, then it will never be within the realm of a scientific theory, and some see that as a significant limit. And I guess one more limitation, some people, including the early modern British philosopher David Hume, criticized the assumption of predictability that I mentioned before. The assumption that the world is orderly and predictable, so cause-effect relationships will be stable and repeatable forever into the future. David Hume and others say, how can you really know that for sure, though? How can you know, for example, that gravity will continue to function as it has in the past? You can say that you expect it to, but until you're in the future seeing it function in the same way, you're kind of just working off of an assumption based on your past experience. And that's induction. But induction itself, as you know, can't guarantee that its conclusion is true. So that's something of a limitation that some worry about. Okay, so there we go. What I've talked to you about so far is just, first of all, the definition of science, who are some important figures in the early history of science, and Francis Bacon. And then we talked about assumptions of science and a couple limitations. So next point that we see in the book is 4 different views about the relationship between science and religion. Okay, so science and religion, much has been said about that they sometimes clash with each other or that they don't always agree on things. What are the ways that a person can navigate the tensions that exist between religion and science? The book says there are basically 4 options for people. So 4 views about the relationship of science and religion. Okay, 4 different views then about the relationship of science and religion. First of all, some people will hold this view that if science and religion conflict, don't see eye to eye on something, some people will say, well, then you should go in favor of the scientific account. So one perspective is that science takes priority over religion when they come into conflict. Okay, so science takes priority over religion when the 2 conflict. That's one position. So think of, for example, some areas where science and religion disagree. One account could be the origins of human beings. Are we the product of a natural process of evolution that takes billions and billions of years of natural selection? Or were we just created in the image of God straight away from the beginning? Some people, creationists, very into fundamental doctrines of their religion, will say science has to be wrong here. God would not have, wanted us to evolve through this series of very gradual changes. He would have put us in his image at the beginning. And that's what you do see in books like the Bible, where in Genesis it says that, in the first 7 days, God created everything. And on the 7th day, he rested, and you had Adam and Eve in paradise and the Garden of Eden, not primates that had to gradually evolve. So what's the, truth? Is it creationism or is it evolution? Well, if you're a person that holds this viewpoint, then when these conflicts arise between the two, you favor science. You say, well, I'm going to reject the religious account and I'm going to go with the scientific viewpoint on what the answer is. So some people in relationship between science and religion, they go in favor of science over religion. The book uses this language. They said, one view is that science trumps religion when the 2 come into conflict. Okay, the word trump, not in reference to the former president, but as a verb, to trump something is to take priority over something else. So like imagine that you could get a good job, but you'd have to move away from your family forever, and you really care about family. You might say, well, look, my family, that trumps everything, so I can't take the job because I put that priority on my family over making more money. Or you might be a person who says, look, money trumps it all, so I love my family, but I'm going to have to take this high-paying job where I'm never going to be able to see him again because money trumps family and relationship. So trumps just means to take priority over something else. But to avoid the confusions and the perhaps false association with the former president, I'm using a synonym, which is to take priority over the other thing. So anyway, science takes priority over religion when the 2 conflict. That's one view. That's one view. So if a person had that view and somebody says, look, at the end of life, when the brain is gone, there's no consciousness, so the person's dead and there's no afterlife. And a religious person says, no, there's a soul and there's an afterlife, you're going to be judged by God. Those 2 views don't agree. If a person holds this position, then they would say, no, the scientist is correct and the theist is wrong. Now, another view, though, it's not the only one. The second one would be like the opposite of this. So just run it backwards. Religion takes priority over science when the 2 conflict. So that's a different point of view, a different way to go. Some people will take it in this direction, and so maybe a more devout adherent to their given religion is going to reject certain scientific information if it runs counter to what they think is the religious truth. So if science is telling you that, look, God put us in the middle, he wouldn't want us rotating around this random gaseous star, he would want human beings to be the centerpiece. But then science like Galileo and Copernicus are saying, no, we're actually observing these things through telescopes, and we can see that we orbit the sun and not the other way around. Well, back then, I mean, today this is kind of a settled issue. Nobody really thinks that we are in the middle anymore. But back then, people holding view number 2 would have said those observations have to be wrong or somehow inspired by the devil or something, because religion tells us something different. So if the scientific research is coming out contradicting those religious views, that's got to be wrong. So this type of person would favor the creationism account of the genesis of human beings over the evolutionary account. And that's just the tip of the iceberg. As you guys know, there's so many different places in life where we hear claims of science that are being contradicted by religion and vice versa. So this is just the type of person who sides with the religion instead of science whenever such conflicts arise. Okay. There's 2 more views though, so I want to get them on the board. We've covered the first 2, so I can clear that space. A third possible position on the relationship of science and religion is this third one, which says that science and religion deal with different topics, so they don't actually come into conflict. Science and religion deal with different topics. So view number 1 is like science over religion if they don't agree. View number 2 was religion over science if they don't agree. Now this third one is trying to finesse like a compatibility or a middle ground between them by saying that actually they don't step on each other's toes because they deal with separate topics. So there's no room for conflict if they're talking about different things. Somebody might say the following: science, that's where you go when you want to learn about material processes of nature, cause-effect relationships, how things work, where things come from. So if you're looking for answers of those kinds, science is where you go. But if you want something that talks to you about the moral side of life, what your values are, the spiritual elements of reality, then you go with religion. But they don't deal with the same topics, so there's no way for them to really step on each other's toes and conflict with each other. The thing, though, is, as much as that sounds appealing, because you basically say, look, I get to have all sides. I have my scientific side that deals with those questions, and I have my religious side that deals with these other questions, and there's no problem with that. As much as that may seem comforting and nice, and it is, there's some room to criticize it because, at least apparently, science and religion do seem to talk about many of the same things. Like in science, there's cosmology, which talks about the early origins of the universe. And in religion, there's also the account of creation given in the book of Genesis. So they don't say the same things. One thing attributes all of this to the agency of a creator God, and the other talks about just the outplaying of physical forces in the early universe. So it's kind of hard in a way to disentangle the areas where they both seem to have contradictory claims. But anyway, if that was your view, you'd really insist that they're not at all on the same topics. Here's what the book says about that. It says, people who adopt the third position deny that there's a conflict. They argue instead that science and religion deal with separate and different exclusive realms. Science deals with the objective, empirical reality. Religion is concerned with values and a subjective spiritual reality. Science asks how and what. Religion asks why. Therefore, we can accept evolution without relinquishing our religious convictions regarding the special creation of human beings in the image of God. But the textbook says what I was just mentioning. One of the problems with this approach, though, is that in some cases, science and religion make claims about the same phenomenon, whether it's the origin of human life, the effect of prayer on healing, the occurrence of the biblical Great Flood. So science says something different than religion on all of those points, and therefore that puts pressure on this perspective because it seems as though it's not viable if they really do have conflicts. But anyway, a fourth and final possible position is also interesting, and that last one just says that when it comes to science and religion, they're compatible with each other. So that's number 4. Science and religion are compatible. Okay, so view number 3 is like they're in their own separate lanes and they don't really cross over and interfere with the topic of the other. But number 4 says, actually, they're really not even saying different things. They agree on everything. And it only seems like they disagree when you don't have the proper interpretation of the scientific or the religious claim. So for example, this type of view is popular with those that try to expand the interpretation of a religious text in order to bring it into compatibility with some scientific discoveries. So, okay, like in science, they say it took billions and billions of years for planets and stars to form, and then for life on the planet Earth to evolve into this highly intelligent bipedal vertebrate animal that we are. And so on scientific accounts, humans appear way late to the party. I mean, the universe was there, just sitting there, and human beings somehow pop into the picture way late, like in the last 100,000 years. Compared to the history of the universe, that's like showing up in the last 1 second before the ball drops on New Year's, and the whole year happened before that. So we're like getting in at the very end, according to science. But on the religious view, no, we were there way in the beginning because God made the whole universe just for the sake of man, and so he did it within the first 7 days. Now, those look like a straight contradiction. It can't be that we were here within 7 days, but also it took billions of years. Well, people who are fond of this viewpoint try to finesse the interpretation of the Bible so that it makes sense with the science. So when it says God created everything in 6 days and on the 7th day he rested, someone might say, according to this view, that, well, it says days, right, in the Bible. But maybe what it meant, do you guys have a way of thinking about how I might finish this thought? How might a person try and spin the account of creation in the Bible to have it make sense with the late arrival of humans in the universe? They could argue or, make the case that when it says a day in the Bible, that doesn't necessarily refer to like a 24-hour day on the surface of our earth, that it's a day in the life and the mind of God. So it could be an arbitrarily long span. So a day, as it's written in the Bible, might actually refer to billions and billions of years. So there's really no difference between what the Bible has said and what the scientist has said. Yeah, so there you go, Edward, exactly. Some people will then try and make these claims that if we simply interpret things properly, we don't see these strong disagreements between science and religion. They just have their own different ways of saying the same thing. So maybe in the same way, you can read other aspects of biblical writings and try and bring them into compatibility with scientific results. Evolution theory, you can say, well, that doesn't contradict creationism because maybe God created the system in which evolution would happen, knowing what its end results would be. And so we don't have to have one or the other. We can have it both ways. The only issue with this, the way I see a problem with this, is that it oftentimes is only that a person modifies their traditional interpretation of Scripture when it's put under pressure by scientific discoveries. But these are not reinterpretations that were thought of in the advance of the discovery. So in a way, it almost seems like, ad hoc. Let's just make this religious claim be whatever we think it has to be so that it matches what science has already told us. Because nobody would have thought the natural interpretation of Genesis, when it says 6 days and he rested on the 7th day, the natural interpretation of that would have been, 6 days as we experience them here on planet Earth. The only reason to try and modify the straightforward interpretation is because scientists have discovered things that run contrary to the literal meaning of the words. So is it really that this was always what it meant? Or is it just that we're trying to rig the explanation to conform to what the scientist has discovered? Think about this. I sometimes think of this metaphor. If you shot an arrow at the side of a barn with no direction or aim, and then you walked up to wherever it lands, and you draw a bullseye around it, that doesn't prove that you're a great marksman. It just proves that you drew the bullseye wherever the thing did end up landing. So I sometimes think of this thing of like modifying past explanations to bring them into compatibility with new discoveries. Whatever the new discovery is, that that's the target, that you have to make this old doctrine match. And so you'll just modify the doctrine however you think so that it does fall into agreement with the current day scientific explanations. But I would have thought it would have been a little more genuine if those were the given explanations to begin with. Otherwise, it starts to seem as though we're straining to bring these things into compliance with each other. But anyway, there's 4 different views. Now, which one do you have? I don't know. We're all different people, right? But that's pretty much the menu of options. You're either going to say, when science and religion don't go together, I'm going to favor science, or I'm going to favor religion. Or I don't even really see them disagreeing because they're talking about different things. Or maybe you hold this view that when it's all said and done, if you look at it the right way, they're not so much in disagreement, but they say the same things. Just take some interpretation to find out how. Okay. So interesting little sidebar discussion of what are these 4 optional views of the relationship between science and religion. Most, working scientists and a lot of members of the academy hold the first view. The more traditional conservative religious practitioner will hold number 2, and then the other options are kind of a mixed bag that you see from time to time. Now, the next step of the chapter 12 science chapter talks about the scientific method, the different steps in the scientific method. So we're going to go over those, and we're going to talk a little bit about how the scientific method is, in some very basic way, similar to the steps in the critical thinking process. After we talk about the steps in the scientific method, we'll talk about how to evaluate scientific hypotheses. What are the qualities of a good scientific hypothesis or theory? And then finally, we'll end with the definition of pseudoscience, or in other words, fake science, and how you can tell the difference between real and fake science and what pseudoscience, fake science is like. So that's really the next couple steps here in our meeting. I think that we have plenty of time to finish this on Wednesday when we return from this little break. So I guess I'll probably stop us here, because for me to launch into the scientific method at this time, I would only be able to cover like maybe one of the points. But this is a more natural stopping place because it falls in the gap between when we finish the talk of science and religion and now when we go into the scientific method. Otherwise, I would have to stop us halfway through the scientific method and then reset and go back into the beginning of it on Wednesday. So even though we have about 5 minutes, I think this will be a fair use of our time. So then, guys, let me know, are we all right? This is just part 1 of the science lecture. Part 2 is Wednesday, and then we will have a little quiz on this material, just this one chapter, next Monday. So that's the upcoming schedule. Okay, perfect. Thanks so much, guys. Have a great day. Don't forget to keep working on that homework. It's not due until the end of Thursday, but I would not want to wait to the very last moment, so if I was you. Okay, perfect. Thanks again. Have a great one, and I'll see you soon. Thanks.